Hello everyone, a warm welcome to today's session, the video number 4 on the chapter acid, base and salt. And in this video, we will be discussing the last topic for this chapter, that is about salts. So we start the discussion of salts by understanding the family of salts. So you can see a table in your screen, and I have put down some salts and their chemical formulae, and we can also see that the information has been given to us that these salts have been formed from which acid and base. So first salt we see is a potassium sulfate, K2SO4. It is formed by H2SO4 and KOH salt reaction. Same way sodium sulfate formed from H2SO4 and NaOH reaction. Calcium sulfate formed from H2SO4 and COCO3 reaction. Magnesium sulfate formed from H2SO4 and MgOH2 reaction. Copper sulfate formed from H2SO4 and CuOH2 reaction, and so on. Okay, so salts having same positive or negative radicals belong to a family. Now, for example, we see a salt NaCl and Na2SO4. Now, what is common in these two salts? Na, sodium. So they belong to family of sodium salts. Same way NaCl and KCl belong to the family of chloride salts, as chloride is common in them. Let's move ahead and learn about the pH of salts. Sodium chloride is a normal salt, common salt. It has pH of 7 and its acid used is HCl and base used is NaOH. Potassium nitrate, again pH of 7, HNO3 and KOH. Aluminum chloride, pH 7, HCl and AlOH3. Zinc sulfate 7, H2SO4 and ZnOH2. So what we see is that most of our salts will have a pH of 7, and they might also have a lesser pH than 7 or greater pH than 7. Copper sulfate has lesser than 7 and sodium acetate has more than 7. So what do we learn? That salts of strong acid and strong base are neutral. See, salts of strong acid and strong base are neutral. 7. Salts of strong acid and strong base are again neutral. So in the first 4 salts, we can see HCl, HNO3, HCl, H2SO4 are strong acids. NaOH, KOH, AlOH3, ZnOH2 are strong bases. So when these two react, strong acid and strong base, they give us a salt of pH 7. Okay. Salts of a strong acid and weak base are acidic and have a pH lesser than 7. We can see this in this case, copper sulfate salt, that a salt of a strong acid H2SO4 and a weak base COH2 are acidic, having pH less than 7. Salts of strong base and weak acid are basic. So strong base and weak acid are basic, having pH greater than 7, like sodium acetate, NaOH, strong base, weak acid CH3OH. Sodium carbonate, NaOH, strong base, H2CO3, weak acid. NaOH, strong acid, weak base, H2CO3, sodium hydrogen carbonate. Okay, pH of some salt samples and the acid and base used to form the salts are given. Okay, so now let's move ahead and see what are some of the important chemicals that we get from common salt. This is a rock salt. Okay, image of rock salt. The salt, common salt, sodium chloride, NaCl, is a neutral salt formed by reaction of HCl and NaOH solution. NaCl is separated from seawater containing many salts. So deposits of large crystals of solid salt are also found in several parts. These are often brown due to impurities. This is called rock salt. Okay. There are beds of rock salt formed when seas of bygone ages dried up. Rock salt is mined like a coal. Okay. Is mined like a coal. And common salt is used in food. It is also a raw material to make sodium hydroxide, baking soda, washing soda, bleaching powder, etc. Let's move ahead and see what are the chemicals we get from common salt. First is we get sodium hydroxide, NaOH. So what is happening? How we are getting NaOH? When electricity is passed through an aqueous solution of sodium chloride. Aqueous solution of sodium chloride is also known as brine. Okay. Brine means NaCl solution is there in an aqueous form, current, and that is called as brine. It decomposes to form sodium hydroxide. It is called the chloralkali process. This can be asked in exam. Define chloralkali process, draw the diagram and explain. Because of the products formed, chlor for chlorine and alkali for sodium hydroxide, Cl2 and the alkali NaOH. 2NaCl plus 2H2O is the reaction. NaCl plus 2H2O, current is passed, so 2NaOH plus Cl2 plus H2 is formed. Cl2 goes from anode, in cathode H2 gas goes, and 2NaOH is the sodium hydroxide solution. Chlorine gas is given off at the anode and hydrogen gas at the cathode. NaOH solution is formed near the cathode. Okay. Now let us see some of the uses. Like we are getting NaOH, we are getting Cl2, we are getting H2. Where are these used? Now let us see the use of NaOH. NaOH is a strong base and it is used in degreasing of metals. Metals usually get grease in them, so NaOH is used to degrease them, to make soaps and detergents. Okay, all the strong bases are used for making soaps and detergents. Okay, for paper making, artificial fibers, etc. Then we see what is the use of chlorine, Cl2, for water treatment in swimming pools. In swimming pools we require water treatment. In that, chlorine is used to make PVC, disinfectants, CFCs, pesticides, etc. Cl2 is used. Uses of H2, it is used in fuels to produce margarine and to make ammonia for fertilizers. Okay, now let's move ahead. Now let us study something about a bleaching powder. All of us have some or the other idea about bleaching powder. First of all, what is asked in exam is the chemical formula of bleaching powder. What is the chemical formula of bleaching powder? CaOCl2. Calcium oxygen chloride. CaOCl2 is bleaching powder. This is how a bleaching powder looks like. CaOCl2. So how is it manufactured? It is manufactured by using chlorine produced during the electrolysis of brine. Previously, we have seen NaCl aqueous and the current is passed through it. That is the brine. While doing the electrolysis, we are getting hydrogen H2, Cl2 and NaOH. In that, we are getting chlorine Cl2. That chlorine is used for the manufacture. That chlorine is used for making a bleaching powder. Chlorine acts on dry slate lime to give bleaching powder. Now this chlorine is made to react with dry slate lime, CaOH2, and we get CaOCl2 plus H2O. This is the bleaching powder. Actual composition of CaOCl2 is quite complex. Okay. Now where is the bleaching powder used? What is the use of bleaching powder? Okay. Bleaching powder is used for bleaching cotton and linen in the textile industry, for bleaching wood pulp in paper factories, for bleaching washed clothes in laundry, as an oxidizing agent in many chemical industries, to make drinking water free from germs. See, the dark color of the pulp is mainly due to residual lignin. This is removed gradually during bleaching. This is pulp bleaching. Okay, we get something like this. Let's move ahead and also understand baking soda. See, baking soda we all know is used in baking cakes. So what is the chemical name of baking soda? Sodium hydrogen carbonate. As you can see, sodium hydrogen carbonate. What is important? Important thing in baking soda is to remember its chemical name, sodium hydrogen carbonate, NaHCO3. And also to remember the chemical formula, the name and the chemical formula, NaHCO3, sodium hydrogen carbonate. It is produced using sodium chloride. Now, what is the process? The process is NaCl plus H2O plus CO2 plus NH3. NH3 is ammonia. NaCl plus H2O plus CO2 plus NH3 ammonia. When all these people react, we get ammonium chloride, NH4Cl plus NaHCO3, sodium hydrogen carbonate. This is how sodium hydrogen carbonate looks like. Okay, clear? It is mild, non-corrosive, basic salt. When it is heated for cooking, following reaction occurs. 2NaHCO3 is heated and we are getting something like Na2CO3, sodium carbonate plus H2O plus CO2. This is a sodium carbonate. Okay, this is obtained while we heat sodium hydrogen carbonate or baking soda. Now where is baking soda used? Uses of baking soda. It is used to make crispy pakoras. Pakoda and tea is famous in India during rainy days in evening. Everyone will have. So baking soda is used for making crispy pakoras. It is added for faster cooking. To make baking powder, baking soda plus mild baking soda plus mild edible acids such as tartaric acid. When baking powder is heated or mixed in water, following reaction occurs. NaHCO3 is our baking soda. It is mixed or reacted with water, so we get H plus ion from any acid. CO2 plus H2O plus sodium salt of acid. CO2 causes bread or cake to rise, making soft and spongy. It is an ingredient in antacids. Being alkaline, it neutralizes acidity in stomach, and our baking soda is also used, and it is also used in soda acid fire extinguishers. Soda acid fire extinguishers. Okay. So our baking soda is also used in soda acid fire extinguisher. Clear? Now let's move ahead and see what is a washing soda. Now this is also a salt. Washing soda is Na2CO3.10H2O. Now what is this .10H2O? .10H2O is known as the water of crystallization. A basic salt obtained from NaCl, NaHCO3, Na2CO3 sodium carbonate is our washing soda. Recrystallization of sodium carbonate is washing soda. Na2CO3 plus 10H2O, we get Na2CO3.10H2O. So what are the uses of washing soda? They are used in glass, soap and paper industries to manufacture sodium compounds such as borax, and it is used as a cleaning agent for domestic purpose. It is also used to remove permanent hardness of water. What is asked in exam? Write down the chemical formula of washing soda, Na2CO3.10H2O. What is asked in exam? Where is the use of washing soda, where it is used? So these are the uses. And which chemical compound is used to remove permanent hardness of water? Washing soda, Na2CO3.10H2O. Let's move ahead. Are the crystals of salt really dry? Heat few copper sulfate crystals in a dry boiling tube. Copper sulfates become white and some water droplets appear in the boiling tube. Copper sulfate crystals contain water of crystallization, 0.5H2O. On heating, the water is removed and salt turns white. See, CuSO4 has water of crystallization, hence they appear blue. When we heat it, they lose their water crystallization and they appear white. When 2-3 drops of water are added, copper crystals restore its blue color as they again gain the water of crystallization. So removing water of crystallization by heating, the color blue has changed to white. Let's move ahead. Now, water of crystallization is the fixed number of water molecules present in one formula unit of salt when they are hydrated. Hydrated copper sulfate is CuSO4.5H2O contains 5 water molecules. Na2CO3.10H2O contains 10 water molecules. Gypsum, there is another compound known as a gypsum. Gypsum is CaSO4 calcium sulfate .2H2O. It contains 2 water molecules. Okay. Now let us study about plaster of Paris. We might all have heard about plaster of Paris. So we have something called as a gypsum. When we heat gypsum at 373 Kelvin, it loses water of crystallization. It loses water molecules and becomes a white powder. This is called plaster of Paris or calcium sulfate hemihydrate, CaSO4.12H2O. Plaster of Paris on mixing with water changes to gypsum again, giving a hard solid mass. This is plaster of Paris, CaSO4.12H2O plus 1.5H2O. So we are getting CaSO4.2H2O, that is a gypsum. Only half a water molecule is shown to be attached as water of crystallization because 2 formula units of CaSO4 share 1 molecule of water. Okay, clear? So I hope this is clear. The concept of gypsum is also important. Now let us see what is the use of plaster of Paris quickly. Plaster of Paris is used as plaster to support fractured bones. When we have fractured bones, plaster of Paris is used to make toys and materials for decoration and to make surfaces smooth. Thank you.